Hello everyone, welcome back to Kali. This is Mr. Pokral. I have a question. Have you ever heard that people saying write cleaner code and you don't know what cleaner code is? It's like you, I also didn't know what clean code was. I didn't know what solid principles were. But I'm creating this series and this is going to be the first episode where we're gonna learn the first alphabet S from solid. We have 5 principles, SOLID. So in this episode we're gonna learn S, which means single responsibility principle. All big companies like Google, Tesla, any FAANG companies want you to write code that follows solid principles or have certain design pattern. So to make you perfect, like you can write any type of code, but writing a perfect, clean, scalable or extendable code, you need to apply these principles. So let's jump into this.
We are learning the S of solid principle, right? Which means single responsibility principle. What does this mean? Single responsibility principle. So this means a class should have only one reason to change. Only one reason to change. What does this mean? Now, a class, whatever class it is, should have only one reason to change. Only one. That means that it should have only one responsibility. One class is responsible for single thing. As a beginner, this is a mistake everybody does. I know the code works fine and it will run fine. There will be no errors. But while you will work in a big softwares with millions of code, then if you write whatever type of class you want, then it gets messy. That's why these solid principles were developed, right? So this means this is the easiest one among the rest of the principles. So this means that a class should have only one principle and it should do only one task. That's it. And if you want to do something else, you need to create a different class. And then if you want them to work together, you need to connect them somehow, right? So whenever you create a class, make sure that it has only one responsibility. That's what this principle says, right? So we are not just going to learn about this principle here, but we are also going to create a to-do app. And not in this tutorial, but when you complete the 5 of the principles, you're gonna have a to-do app in your project list. You can keep it on your resume, and if you show this code to your recruiter, then they will not just see a running code, but also understand that you know how to manage your code base. And all the big companies, they see these kinds of codes. All right, so without any further discussion, let's move into the code. So I'm gonna create a task class. See, so this class here, see, I'm gonna show you how a beginner will write his classes. It will not take me like that long, so don't skip, please do not skip, because I want to show you the wrong thing so that whenever you do a project later on after watching this tutorial, you should know what to do and what not to do. I'm not just going to teach you the theory, but I also want you to see from the application, from this project, and how to use these principles. So I know a lot of to be honest, some people know these principles, but they only know the concept. They don't know how to use it. And later on, when they write the code, they write the same messy code, same spaghetti code. And in the small code base, it works fine. But like I said, in a big code bases, you need to manage your code well. It needs to scale whenever you want. It needs to adapt to the changes. See? So for that, what I'm going to do is I'm going to show you how general people write their classes before learning solid. So I'm going to have 2 members into this task class. So this is going to be a this is going to be a to-do class, right? To-do application, right? So for this, I want to have a private variables. So in to-do, we have 2 things. One, a task name and the status. For task name, I'm going to use a string and let's say description. So this is going to store the description of our task, and then I'm gonna have a boolean variable to store the status, if it is completed or not. So I'm gonna have two variables and it's private. Now as a public, I want to have different methods into this class. For example, I want to add values to this description. That I'm gonna do it in a constructor. Let's say I want to get the task, so I'm gonna create standard string get description. This is going to be one functionalities, one feature, and second is going to be, let's say, void is completed. This is going to mark the task as completed, and void to get if the task is completed or not. I'm going to say what status. So this is going to return you the status of your task, right? And I want to create one more, add task. See, and then I want to add one more feature, is remove task. Please don't skip, okay? So I'm writing a code, try to understand what I'm trying to do, and it does feel right. It will work. It works good. There's no error, there is no bug. This code will work. And void this display task. See, I have these functionalities. I'm gonna have these feature in our to-do app, and I have these functionalities in our task. So what is the problem here? Does it actually work with the solid principle? No, it doesn't even align with the S of solid, which is single responsibility principle. I have like too many responsibilities inside this task class. It has responsibility of storing these values of a single task. It has responsibility of adding task, removing task, and also getting the status or whatever. And it also has a task of showing it, which normally happens in GUI part of the application. So I have every feature that I need in the to-do app inside the same class, which is like I'm forcing it to work. Imagine a programmer, and his job is only to write a code, but he gets asked to fix the printer, he gets asked to make a sandwich, he gets asked to clean the desk. It's not that he cannot do those jobs like here in this code. It's not like that this class will not handle these codes, but it shouldn't handle this. Just because the programmer can fix the printer or make a sandwich doesn't mean that he has to do that. That's not his responsibility, right? His responsibility is to write a code. If I only give him the responsibility of writing a code, then he's gonna write a good code, right? His only focus is to write the code, and if he's not able to fix the printer, it's not his problem. I need to go to a person who can fix the printer. Let's say a admin guy whose work is only to fix the hardware or some of those things. So I'm going to divide these these responsibilities because single responsibility principle says so. So for this, what I'm going to need is I'm going to make some more classes. This is going to be a task manager, and our task manager is going to be responsible for adding a task, removing a task here, and then I'm gonna have one more class for displaying the output, displaying our to-do app task and description. So what I have here is, I'm just gonna pull this here. So now if you see, this follows single responsible principle. This class is only responsible for storing data for a single task, right? So this is only responsible for storing data. This class is responsible for what? For adding removing and changing status, let's say status of the task, and this is to display or to show the task. See, now responsibility has been divided. If I have a problem in adding or removing tasks, I'll just come to this class and change it here. If I have a problem with showing anything onto the screen, then I'll come and fix it here. I don't need to touch any of other classes. So I have divided responsibility by this. When there is a problem, I can come to that responsible class and fix it here. I don't have to go to a long line of codes and find what I'm like missing, where the missed part is. If I have everything into this class, and if it's a big code base, let's say 5,000 lines of code, then I have to scroll and find it out. And if I change it, it's gonna affect all the other members of the classes inside that class. But now I have a different classes. That means that it's not messed up, it's not coupled. A single class is responsible for a single thing. I can fix it there, or I can manage it there. It's more manageable. This is more scalable. So this is more professional. Now we're gonna make a skeleton for our to-do app, and in our next episode where we learn open closed for O in solid principle, we're gonna make a skeleton right now and then apply open closed principle in our coming tutorial. So let's do it right now. So if you don't want to make a to-do app, then if you just wanted to know the concept, this is how we write single responsibility. This is how we separate the responsibility for the classes. See, this class is responsible, single thing, single thing, single thing. This is what the principle says. So let's write some code. I want you guys to complete this project too, because I want you guys to have this on your resume. And if somebody sees this code in your resume, they'll say like, oh my god, this guy knows how to code. It might look like a basic app, but you have managed a code in a professional way, and it shows your knowledge. So in this task, what I'm gonna do is I'm gonna write this functions. So to get description, I'm gonna return this description, right? So description, this just returns the description. Void is completed. So what does it do? It says like make it complete. So whatever the task is, put the status is equal to true. So if is completed is used, then you have to, it changes the status of the task as completed. And what status will return the status of that task? Return what status? All right, seems good. And I'm gonna create a constructor task, and then this constructor is going to take an argument of string task, and I'm going to store this task inside the description. So description is going to have this task, and when you create this task, I want the status to be false. Status false, that means that the task is not completed, right? Whenever you create a task, it's obvious that it's not completed. You have to manually hit a completed button after your completion of that task. That's how the normal to-do app works, right? So we're just writing the logic. So this is just for our task class. It's only responsible for storing data for a single task. That's it. Now we're gonna manage these tasks, this class. So each individual classes have what? Have description and a status, and we're gonna have to store those tasks into a list, right? So that it comes as a list: task 1, task 2, task 3. And to keep it on a list, let's create a vector of what? Type task, because we're going to store our tasks in this list. And I'm gonna make it private, and we have few responsibilities here. So these methods are going to be public. and we have the first one as add task. So here what we're going to do is we're going to add task into this list. To add that, what we are going to do is task dot, this is the vector, right? In place back, what are we going to in place back? The task name, right? Which is a task name, which is a description. Let's say description. So we have not passed it as an argument here. So whenever you say add task and then you give the name of the task, and it's going to be stored here, standard string tax name, and then this is also going to be a tax name. Let's say this is for the clarity, okay? And what is happening here is, why did I use in place back? And see here, this vector is a type of task, is storing a type as task, but I am putting a value as a description. How does it work? See, I'm not trying to confuse you guys, but this task, this list is supposed to take only the type of task, not the type of string. But I'm pushing what? String. I'm pushing a string into this vector which only takes a class task, because this is how in place back works. If I use push back here, this is not going to work. I have to say tax, and then now this works fine too. What is happening here? If I do push back, then what I'm doing is I'm creating a constructor and putting this string on this description here, and then storing it in a description, right? This is how it works. But normally the difference between the pushback and in place back is, pushback, what it does is it's gonna create a tags first and then copy it inside the vector. But in place back, it directly makes a class object inside the vector, so you don't have to create a constructor. It directly creates a class, sorry, it directly creates the object inside the class in place back. So if you want to use a pushback, you can use it like I showed you. So directly this is going to create an object with this constructor description parameter directly into the vector. All right, this as a task for us into the list. And to remove a task, what I want is, how do we know that which task to remove? So we're gonna take an parameter as index. So whenever user gives the index of the task, it's gonna remove that task from the vector list. So this, then I'm gonna check if index is greater or equal to 0, because it shouldn't be less than 0, right? So index shouldn't be less than 0, and index shouldn't be greater or equal to, sorry, shouldn't be greater than the size of what? Size of vector, but our vector name is tax dot size. So this size function returns the size of the vector, and if this is true, that means that the index is, the user input is right inside the vector. It's not a value that is way big. Like say we have only 5 tags, and then if user puts 7 to delete, then it says no, that's not happening. This is to check. So if this is true, if the index lies between the size of the vector, then we're gonna say remove it. And to remove, we're gonna say vector, this is a tags list, erase what? Tags dot begin plus that index, whatever index you have given, erase that. So this is going to erase the tags that you have given as a parameter. And what else do I need here is, I want to return the tags list to display it here. So for that, what I want to do is, I also want to void completed. See, I also want to mark complete, and it's also going to take index, because user should know which one to mark as complete. So I'm also gonna check if user has input the right value, and if it is inside the size, then I'm gonna say task and index dot index what is to mark is completed is completed. So this gonna mark that index as completed. Okay, seems good. And then I need one more, which is going to return a vector. So standard vector, this is of standard vector type task, actually task, and this is going to return get task, and this is going to return what? List of tasks, list this task, tsks task. Sounds good to me. So okay, so we have this function here, and I just want to make it static. See, why do we need static? I'm gonna explain this. Okay, so void static for display task, I'm gonna make a vector here. This is going to take a vector because we're gonna use this vector, and this takes a task, and let's say task. All right, standard cout. So this is only responsible for displaying the task, right? So standard cout, what I'm gonna say is I'm gonna have a for loop here for int I 0 I is less than what? Task dot size it should be less than the size of the list, and I plus plus, and it's gonna iterate over the list of the task. And for each task, I'm gonna print all the tasks and the status. So standard cout, first of all, I'm gonna print the index so that the user knows what to remove or mark as complete. Index and the task description, right? So task dot get description. Oops, do we have like, okay, we have like get description here inside of the, right? Okay, task index and then get description. Oh, sorry, it's going to be I, right? Get description, this is right? Get description, that's good. And after this, I'm also gonna give the status and task as index, and then what is status is going to return the status of this index task. So I'm hoping that you already know these basic C++, right? And I'm gonna say and L. Seems good for me. Yeah, all right, seems fine. See, this will work fine. So I'm also gonna show you what this static does. Okay, here, first of all, I don't even need to create this class task. No, I don't need it. Straight from the task manager, I can create a task with the help of add task, right? So task manager task and task dot add task is going to be was close. This is going to be the first task, and tax 2 is going to be add tax is going to be do this as, let's say this is going to be a second task. So right now I'm going to show you why I use this static, right? So without, see, for this task manager I had to create an object called task, and task.add task, these functionalities, these methods were only be able to used because I had to create an object, right? But for if you use static, you can directly call it without having to create an object. So display and this display task, and what does it take? It takes the vector of the task. So to get the vectors, get task. Okay, so task dot get task is going to give you the list of the vector. Display task is a private member. Oops, sorry, gotta make it public. Oh, public. All right, perfect. So let's see, I should be able to see two tasks as task 0 as was closed, and do this as C. So task was closed, and do this as both are 0 0, that means both are incomplete. So for example, if I say task dot completed and 1, let's say I completed the index 1, that means that I should get a value of 1 in do this as, that means true. All right, allow do this as 0 1, do this is still 1, this should completed is completed is going to status true. Let me rerun this again. Allow, oh, I still get 0, I don't know why. Let me fix this. Task completed is going to, I'm giving it a index, is going to go check index. If index is greater than 0, sorry, you know why I shouldn't have. Yo, completed task 0 is complete. What is happening here? I don't know what is happening. Less than. I messed up big time. All right, this is working. All right, this is working. I just made a typo here. Okay, so this is working. See, this is a basic to-do app, and this follows single responsibility principle. See, one class is responsible for a single thing, and I also made a simple to-do app in a console, and we're gonna extend this to-do app while we learn other principles too. I know it's a bit longer than normal tutorial, but I also taught you something new. I also taught you how to use these principles, and I'm going to show much more in the coming tutorial. And by the end of this series, you will have a big to-do app with all these functionalities. Not big, but you know how to, you're going to know how to use these principles. And if you request me, I'm going to make a GUI in Qt with an actual application of this tool, of this same code. If you want that, I'm gonna make one more video. There's going to be 5 videos for the principles and one more for creating that application of to-do using the same code that you write while learning Solid. So thank you so much. I'll see you in the next tutorial where we're gonna use open closed principle in the same code and improve it much more.